So let's take a look at some problems we might see in section 2.4, literal equations. We have some equations like this, an expression in which we are given values for x and y. So we're going to rewrite the expression, but we're going to replace x with a value, and we will replace y with a value. So x is equal to 3. So everywhere an x appeared, I'm going to put a 3. And since y is equal to 4, I will plug in a 4 anytime we saw a y. So let's simplify this. 3 times 3 is 9. Negative 2 times 4 is negative 8. Bring in the plus 5. On bottom, 3 times 4 is 12. Minus 2 times 3 is 6. And now we can simplify what we have in the numerator and in the denominator. 9 minus 8 is 1. 1 plus 5 gives us 6. Over 12 minus 6 is 6. And of course, we reduce our fraction. And in this case, 6 over 6 equals 1. So that's one kind of problem you might see. And here's another. We will evaluate x minus y over 4 when x is 4 more than 5 times y and y equals 7. So we are given a value for y, but we are not given a value for x, but x is described. So we can say that x is 4 more than 5 times y. So 4 more than is addition, and 5 times y looks like 5y. So 5y plus 4 is x is equal to 4 more than 5 times y. And we have a value to plug in for y. It tells us what y is. 5 times 7 is 35, plus 4 is 39. So now I have a value for x and y. Now we are ready to evaluate this expression. I will replace x with 39. I will replace y with 7. And this is over 4. So 39 minus 7, we can simplify the numerator here. That's 32 over 4. And 32 divided by 4 is 8. So that's another kind of question you might see. And then you're going to see these solve for the specified variable problems. And this is all about trying to see if we understand how we can move pieces around in an equation. So for number 3, we are solving for s. So before we can completely isolate s, we need to isolate the term containing s. So I want to get Sx by itself by subtracting a from both sides. A plus positive a minus a goes away, and we are left with y minus a equals Sx. And now we can get s by itself by dividing both sides by x. And that's where we can stop. S is equal to y minus a over x. Another problem you might see, something similar to. Here we have g equals 1/5 dz. So this is 1/5 times d times z. We need to get rid of the 1/5 coefficient. So the opposite of to divide by 5 is to multiply by 5. Anything I do to one side, I need to do to the other. So now we have 5 times g, that's 5g, equals, I don't need this coefficient of 1, because 1 dz is the same as dz. And now we can completely isolate the specified variable d. To get rid of this z that is being multiplied, we divide it out. And we do that on both sides. So d is equal to 5g over z. Finally, a problem like number 5, in which we want to isolate c. A couple of things are happening to c right now. It's being divided by 6, and there is also a 78 being added. You're probably going to recognize that we need to get rid of this denominator of 6, but we don't want to multiply until this term is completely isolated. So again, we need to isolate our variable term, and I will do that by subtracting 78 from both sides. So now I have c over 6 equals 6f minus 78. So now we can multiply out the denominator. So I can multiply the left side by 6, and now c will be by itself. I need to multiply the right side by 6. And this is where some students will make a mistake. We're not just multiplying the first term by 6. When I multiply two terms or multiple terms by a single number, we do so via distribution. So again, if you have multiple terms on one side of the equal sign, you need to distribute the number that you're multiplying. So 6 times 6f is 36f, and 78, or negative 78 times 6 is negative 468. So, I hope that helps, and I'll see you next time.